Hi, in this video we are going to correct exercise number 3 and exercise number 4. So in exercise number 3, first part, solve the following. So we have a len equation. So before starting to solve a len equation, we have to determine its domain of definition. So everything inside Ln should be positive, and x minus 4 should be positive, and x greater than 4. X also positive. So x positive and x greater than 4. So the domain is 4 plus infinity. So here, domain x minus 4 positive. So x greater than 4. X positive. So x positive and x greater than 4 both give domain is from 4 till plus infinity. Now, to solve this equation, we have a property that says n or len x to the n equals n len x. So this property, len x to the power n len x, and if we have n len x, we can put it as len x to the power n. So here, 2 len x minus 4, I can put it len x minus 4 square. Len 2, 2 len 2, I can put it len 2 squared. So len x minus 4 squared equal len x minus len 2 squared. Also property len a minus len b is equal len a over b. This is why len x minus len 4, it becomes len x over 4. Now we have len equal len. I can remove len with len. So x minus 4 equal x over 4. By expanding, x minus 4 square is x minus 4 square is x squared minus 8x plus 16 equals x over 4. We cross multiply, we get 4x squared minus 32x plus 64 equal x. We bring x to this side, we see 4x squared minus 33x plus 64. 33, no, hide the x, we take it to the left side, it becomes minus x, it will be minus 33x plus 64. Second degree equation, so we solve it by using the calculator. By using the calculator, mod equation 3, we get x equals the first x and x double prime. It is approximately 5.12 and 3.11. We have to remember that the domain is 0 or 4 plus infinity. The first value is accepted because it belongs to the interval 4 plus infinity, and the second value is rejected because it doesn't belong to the interval 4 plus infinity. Okay, this part, the total mark on this part is 1 point. Second part is len x squared minus 3 len x minus 4 equal to 0. It is like a second degree equation in len x. So by using the calculator, first the domain is 0 plus infinity. Everything inside Ln positive. So domain is 0 plus infinity. By calculator second degree equation, we get, the calculator give x equal minus 1, but here it is not in x, here it is in len x. So you have to pay attention to put len x equal minus 1 and len x equals 4. So to remove this len, we have to solve an equation that contains len. We have, if len x equals a, it means that x equals e to the a. So we remove len, we add e to the next side. So here in this exercise, we have len x equal -1. To take this len, I put e on the next side, x equal e to the -1. It is accepted. It belongs to the interval 0 plus infinity. Here also len x equal 4, so x equals e to the 4. Also, it is accepted. Now this inequality. So to solve this inequality, first we have to state the domain of definition. So everything inside Ln should be positive. 2x plus 1 over x minus 2 first should be positive. 2x plus 1 over x minus 2 is positive. We find the roots. 2x plus 1 equal to 0. We get x equal minus half. X minus 2 different from 0. X different from 2. We get 2. Minus infinity plus infinity here. So we get positive, negative, positive. We can take 0, for example. 0 is between minus half and 2. Between minus half and 2, if we put 0, we get minus half. So it is negative here, positive, positive. So we need the 2x plus 1 over x minus 2 is positive. So the domain of definition is minus infinity minus half union 2 plus infinity. Now, to solve this inequality, on the left side we have Ln, while on the right side we don't have Ln, so we add Ln. 0 is Ln1. So I can put here Ln 2x plus 1 over x minus 2. Instead of 0, I can put Ln1. I can skip Ln with Ln. So 2x plus 1 over x minus 2 is greater than or equal to 1. You have to pay attention that whenever we have inequality, we cannot cross multiply as you have done in the test. So you can never cross multiply with inequality. So we take 1 to the left side. So 2x plus 1 over x minus 2 minus 1 greater or equal to 0. We take 1, it becomes minus 1 greater or equal to 0. We take the LCM, which is x minus 2. 2x plus 1 minus 1 times x is minus x. Minus 1 times minus 2 is plus 2. 2x minus x is x plus 3 over x minus 2 is greater or equal to 0. Sign table for this one. So x plus 3 equal to 0, x equal minus 3, x minus 2 different from 0, x is different from 2, negative infinity, positive infinity. So if we take 0, which is included between minus 3 and 2, if we put 0 here, I get negative, positive, negative, positive. I need a solution greater or equal to 0. So here should be minus infinity minus 3. It should be closed at minus 3. Correct it, please. It should be closed at minus 3. Union 2 plus infinity. Here it is open. Correct. This, okay, 1 point for this exercise. Now we have to solve this system of inequalities. The first equality, afwan, no Ln. It is independent of Ln, while in the second inequality, it is dependent on Ln. So I have to skip Ln. So first, stating the domain, x is positive, y is positive. Everything inside Ln should be positive, so x is positive, y is positive. So here we have len a plus len b, len a plus len b. It is len a times b. It becomes len 2xy. This to len 3, it becomes len 3 squared. Whenever it becomes len 3 squared plus len 2, this here len 3 squared times 2, it will become len 18. So x positive, y positive, as I have said, the domain. Len x I can write len 2y, I can write it len x plus len 2 plus len y equal to len 3 plus len 2. Len 2 and len 2, 0. So len x plus len y, len a زائد len b, we get len xy. Len 2 len 3, it becomes len 3 squared. I skip len with len, so x times y equal 9. So I get two equations, x times y equal 9 and x squared plus y squared equal 18. The first equation is xy equal 9, x squared plus y squared equal 18. So the easiest way is to find y in terms of x or x in terms of y. So here y equal 9 over x. I replace y by 9 over x in the first equation. X squared, instead of y, I put 9 over x squared equals 18. So x squared, 9 squared is 81 over x squared equal 18. I take the LCM. The LCM is x squared. X squared times x squared is x power 4 plus 81 equals 18. Cross multiplication. So we get x power 4 plus 81 equal 18x squared, and x power 4 minus 18x squared plus 81 equals 0. So I will repeat to solve this equation. Here we have two equations with two unknowns, but the first equation is independent of ln. The second equation contains ln, so I have to remove the ln. To remove the ln, I put len 2y first. I can put it len a times b is len a plus len b, len 2 plus len y equal to len 3 plus len 2. Len 2 and len 2, 0. Len xy, len x plus len y, it becomes len xy equal len 3 squared. Skip ln with ln, then xy equal 9. So here I get two equations, xy equal 9 and x squared plus y squared equal 18. I solve this system by the method of substitution. The method of substitution, I find y in terms of x or x in terms of y and replace it in the second equation. So here y equals 9 over x. I replace y in the first equation, so x squared instead of y, 9 over x squared equal 18. X squared, 81 over x squared equal 18. The LCM is x squared times x squared, x power 4 plus 81 equal 18. We cross multiply, we get this equation. This equation is called a biquadratic equation. To solve biquadratic equation, I let t equals x squared. T should be positive. T equal x squared. T is positive because t equal x squared, well, x squared is a positive number. So this x power 4, it becomes t squared. X squared becomes t plus 81. Okay, by using the calculator to solve a second degree equation, this equation has only one root because delta equal to 0. The calculator will give t equal 9, not x, t equals 9. Pay attention. The calculator will give x equal 9, but here it is not in x, this equation, it is in t. So t equal 9. So x squared equal 9 will give x equal 3 or x equal minus 3. But x equal minus 3 is rejected because from the domain x is positive. This is why I take only x equal 3. By replacing x equal 3 in the equation, y equals 9 over x. So y equal 9 over 3, it will be equal 3. So x equal 3 and y equal 3. Now we go to the problem. In this problem, we have a function g. defined by over 1 minus x squared, defined on 0 plus infinity by gx equal 1 minus x squared minus ln x. First part, we need to calculate limit as x tends to 0 and limit as x tends to plus infinity. Limit as x tends to 0, we replace x by 0. It becomes 1 minus 0 minus ln 0. Ln 0 is minus infinity. Minus infinity times negative, it becomes plus infinity. So as x tends to 0, 1 minus 0, ln 0 is minus infinity. So we get 1 plus infinity, which is plus infinity. Now the second limit as x tends to plus infinity of gx, it becomes 1 minus infinity minus infinity. It is simple. Minus infinity is minus infinity. Study the variations of g, then set up the table of variations. Study the variations of g and set up the table of variations. Study the variations means we have to find the derivative. G prime x, derivative of 1 is 0, derivative of minus x squared is minus 2x, derivative of ln x is 1 over x, and we have minus, it becomes minus 1 over x. So g prime x equal derivative of minus x squared, it becomes minus 2x. Derivative of ln x is minus 1 over x. Pay attention that this derivative is negative because domain is 0 plus infinity. Not necessary to take the LCM. So it is negative. So x, we put the domain 0 plus infinity. Pay attention. G prime x and gx, not g and g prime. G prime first, then g. Since it is negative, it is decreasing. At 0, it is plus infinity. At plus infinity, it is minus infinity. 3/4 for this part and 1 point for the first part. Calculate g of 1, then deduce the sign of g over 0 plus infinity. G of 1, then deduce the sign of g over 0 plus infinity. Now, to deduce the sign of g of 1 first, g of 1 becomes 1 minus 1 minus ln 1. 1 minus 1 minus ln 1. Ln 1 is 0. 1 minus 1 is 0. So g of 1 equal 1 minus 1 minus ln 1. Ln 1 is 0, so we get 0. To deduce the sign of g, here I put 1 on the table. If you notice that between 0 and 1, the function is decreasing from plus infinity to 0. So between 0 and 1, the g is positive. From 1 till plus infinity, g is decreasing. From 0 to minus infinity means g is negative. So I can put gx equal to 0 for x equal 1, gx positive x between 0 and 1, and gx negative for x belongs to 1 plus infinity. Gx is negative is x belongs to 1 infinity. 3/4. Or I can do the following. I can make a table like that. This is x. This is gx. I put here the domain 0 plus infinity. Here I put 1. And here it is 0. So if you notice that I can take a number between 1 and infinity. Gx was x squared minus 1 minus x squared, 1 minus x squared minus ln x. If we take a number greater than 1, like 2, and we replace it here, we get negative, positive. So this is the sign of g. إذا لقينا g of 2 برجع بقول 1 minus 4 minus 3 minus ln 2. تطلع minus 4.7, which is negative. Here it is positive. So to deduce the sign of G, this is the sign of G. Between 0 and 1, it is positive. From 1 till plus infinity, it is negative. Now, this is about part A. Now, part B. We have another function, fx defined on 0 plus infinity also by fx equal 1 minus x plus ln x over x. And C is its representative curve. Once again, we need to calculate the limit as x tends to 0 of fx. Limit as x tends to 0, we replace x by 0. Ln 0, 1 minus 0 is 1. Ln 0 is minus infinity over 0 plus, it will be minus infinity. We can deduce an asymptote from here. So limit as x tends to 0 of fx, 1 minus 0 plus ln 0 plus over 0 plus. Ln 0 is minus infinity. So we get minus infinity. We can deduce that x equals 0 is a vertical asymptote. Now limit as x tends to plus infinity, it becomes 1 minus infinity. We have a property that says limit as x tends to plus infinity of ln x over x is 0. Ln x over x as x tends to infinity is 0. And if you don't pay attention for this rule, it will be infinity over infinity by Hospital's rule. Hospital's rule, pay attention, but we do it to this part, to ln x over x, not to all the function. So we get 1 over x, limit of derivative of ln x, 1 over x over 1. This one will become 0, and the limit will be equal minus infinity. 3/4 about this part. Show that the straight line, 3 part A, show that the straight line of equation y equal minus x plus 1 is an oblique asymptote to C. How to prove oblique asymptote? To prove oblique asymptote, you should prove that limit as x tends to plus infinity, not x tends to plus or minus infinity, as x tends to plus infinity is equal to 0. Limit of fx minus yd as x tends to plus infinity equal to 0. So, sorry, this part is not written. So limit the fx as x tends to plus infinity will be 0. It is here. So fx minus yd is ln x. Fx minus yd equals 1 minus x. This is fx minus yd equals ln x over x. So limit as x tends to plus infinity of fx minus yd equal limit of ln x over x. We have it as 0. Therefore, the line D, since the limit as x tends to plus infinity ln fx minus yd equal to 0, then we can say that the line D of equation y equal 1 minus x is an oblique asymptote to C at plus infinity. Okay, I skipped part 2. Part 2, show that f prime x equal gx over x squared and set up the table of variations. F prime x equal gx over x squared. F prime x, to make the derivative of 1 is 0. Derivative of minus x is minus 1. And here it is of the form u over v. U prime, derivative of ln x is 1 over x times v, which is x, minus v prime, derivative of x1, we get minus ln x over x squared. So it is equal minus 1 plus x and x will be simplified. We get 1 minus ln x over x squared. We take the LCM, which is x squared. X squared times minus 1, it is minus x squared, plus 1 minus ln x over x squared equal gx over x squared. It means that f prime x has same sign as gx. F prime x has same sign as gx. Remember that in the previous part here, sine of gx here, it will be positive between 0 and 1. So here, in this table of variation, I put here 0 plus infinity and I put 1. As we have seen before, between 0 and 1, g is positive, so f prime is positive. Between 1 and plus infinity, g is negative, so f prime is negative. Then we get, at 0, we get minus infinity. At plus infinity also we get minus infinity. And f of 1, we replace it in the function, we get 0. Now study the relative positions between C and D. Okay, to study the position of between the curve and the line, you have to study the sign of fx minus yd. Position between C and D is determined by the sign of fx minus yd. Now, fx minus yd is equals ln x over x. It is not positive nor negative, so ln x could be positive and negative, while x is positive. Pay attention. fx minus yd equal ln x over x. So ln x over x equal to 0 means ln x equal to 0, x equal 1. نعمل table here, fx minus yd, and here we put position, domain 0 plus infinity. The value of x1 here, we put it here on the table. Now, I put 0 here. I take a number greater than 1 and replace it here. If I take x equal e, for example, بصير ln e over e, يعني بصير 1 over e, which is positive, and here negative. Positive, يعني c is below d. Negative, يعني c is above d. 1, معناتها d cuts c at 1. To find where it cuts, we replace it in the equation of the line or in the equation of the curve, which is fx. So for x equal 1, the line is 1 minus x. So 1 minus 1 is 0. We get 1, 0. Now part 4, the equation of the tangent d at the point A of abscissa E. To see at point A on C of abscissa E. So A هي E y over A. YA equals f of E 1 minus E plus ln E over E. Ln E is 1. We get 1 over E. So this is f of E. We leave it. We don't change it to decimal. We leave it like that in the exact value. F prime of E to calculate the slope equal minus E squared plus 1 minus ln E over E squared. So I get minus E squared over E squared, which is equal minus 1. And the equation of the tangent here, y minus ya equals slope, which is minus 1, into x minus xa is e. So we simplify, we get y equals minus x plus 1 over e. It is an easy part. Now, part 5, determine the coordinates of a point B on C. Tangent to C at B is parallel to D. Okay, two lines are parallel if they have the same slope. Slope of the tangent equals slope at D. Slope at D from here, it is minus 1. Slope at tangent is f prime. So by solving f prime x equal minus 1, we can find x, so we can calculate the abscissa of the point B. So T parallel at D, slope at T equals slope at D. Then slope at T is f prime x, slope at D is minus 1. F prime x we have calculated minus x squared plus 1 minus ln x over x squared equal minus 1. By cross multiplying, we get minus x squared plus 1 minus ln x. X squared times minus 1 is minus x squared. Minus x squared 0. 1 minus ln x equal to 0. Ln x equals 1. To remove ln here, I can add e to the next side, so x equal e. So here also we have a equal e, so b is the same point as a. 3/4 about this part. Draw C, D, D in an orthonormal system. Draw C, D, and D in an orthonormal system. So, first we have the line y equal 1 minus x. The line y equal 1 minus x. This is the line y equal 1 minus x here. For x equal 0, y equal 1. This is the point. For x equal 1, y equal to 0. This is the other point. So this is the line D. Tangent, A is, or B, the same, is 2.7. B is 2.7 minus 1.3. This is point B or A. And it will be parallel to the line D. This is the tangent. It is parallel because they have the same slope. So one point is enough. We know A or B, which is the same point, and we draw a line parallel to the asymptote. Also, we have the vertical asymptote x equal to 0. From the table of variations, x is increasing from 0 minus infinity to 1, 0. It's increasing from 0 minus infinity from here to the maximum 1, 0. Then it will decrease to minus infinity. So here it will make a tangent at A. Then it decreases near the oblique asymptote. Decreases besides the oblique asymptote. Part 7. Let t be a real number greater than 1. T is a real number which is greater than 1. AT is the area of the region between C and D. And the two lines of equation x equal 1 and x equal t. As you know that the area between a curve and a line equals integral from a to b, which is 1 and t, fx minus yd. Why fx minus yd? Because the curve is above. I put it in absolute value. 1 let t fx minus yd, it will be equal integral from 1 to t ln x dx. So here, as you know, we have integration that contains ln, and we have x in the denominator here. So we solve it by the method of substitution. So we take u equal ln x, derivative u equal 1 over x dx, and dx equals x du. Then we change the variable, which you have to pay attention that we have to change the bounds. For x equals 1 here, u equals ln 1, which is 0. For x equal t, u equals ln t. Now, the area will be equals, 1 is changed into 0, t is changed into ln t, ln x, we put instead of it u, dx is x du over x, x to x simplified, we get integral of u du, integral of the power. You add the power by 1 and we divide by the power. You get u squared over 2. U power 1, you add the power by 1, it will become u squared over 2 between 0 and t. We replace u by ln t. This is ln t, not t. It becomes ln squared t over 2. 3/4 about this part. Now the last part in this test. Calculate t for at equals 2. At equals 2. So we have an equation. We put at equals to 2. At is ln squared t over 2 equal 2. So ln squared t equals 4 by cross multiplication. Then ln t equals 2 or ln t equal minus 2. So ln t equals 2, it means t equals e squared, which is equal 7.38, while here t equal e to the minus 2. And we know that t is a number here. We have t is greater than 1. T is greater than 1. So this one will be rejected. This is all about this test. الو الو صباح النور، كيف احوالك؟ وانت بخير، تنعاد عليك بالصحة.